Good evening, everyone. My name is Rahul Kumar, a second year PhD scholar from the Department of Mechanical Engineering. I will deliver my engineering mechanics lecture. Okay, this is the GATE engineering mechanics syllabus. So, that is free body diagram, equilibrium, friction, applications, trusses, virtual work, kinematics, dynamics, etc. This is the tentative syllabus schedule which I will follow. The first 4 week will consist of statics part, and after that I will follow kinematics and dynamics. Okay, this is the textbook which you should follow. Actually, this textbook is really good. This is my personal favorite. This is engineering mechanics from Mariam and Craig. Okay, if you want to solve some problems, so definitely you can follow this book. So, what is mechanics? So, mechanics is actually the science that describe and predict the condition of rest or motion of bodies under the action of forces. Okay, in our engineering, we actually study three types of mechanics. The first one is mechanics of rigid body, mechanics of deformable bodies, and mechanics of fluid. Mechanics of rigid body, we will study in engineering mechanics. Okay, and mechanics of deformable body, we will study in strength of material, and mechanics of fluid, we will study in fluid mechanics. And for the rigid body is subdivided into two parts, statics and dynamics. Statics is actually deal with bodies with at rest. Kinetics and dynamics deal with body in motion. Okay. And in this part, we will actually study velocity, acceleration, pressure, force, torque, momentum, angular momentum, etc. So, in engineering mechanics, when we solve problems, we usually see a word particle, particle and rigid body. Why we usually see a particle is moving in this direction, a particle is moving in that direction? Why? What is the advantage? I mean, what is the benefit of taking this an assumption? Okay, so the reason is because we assume a particle, a very small matter, very small amount of matter which occupy a single point in space, so that every force any every force and pressure will pass through that point, you know so we don't talk about any dimension. Okay, and the biggest advantage is, we can assume that every force will pass through the particle, and we can neglect the word of center of gravity, because when you talk about the finite size rigid body, then definitely we will talk about the torque moment. You know what? Why? Because when force we apply at certain distance, okay, at certain distance, then definitely the torque will be there. Okay, but in particle there is no distance type of words. Okay, we don't talk about torque, okay, in particle. So now, what is the rigid body? So everybody knows that rigid body consists of large number of particles occupying fixed position with respect to one another in a fixed way. Why I am using with respect to one another? Because rigid body can also translate, can also rotate. Okay, we usually use the word with respect to other, or you can say relative. I mean, in rigid body, the relative position between 2 points doesn't change. So that is the definition of rigid body. Okay, in entire engineering mechanics, we will use six fundamental principles. The first principle is parallelogram, law of addition of forces, then principle of transmissibility, Newton's three laws, okay, Newton's law of gravitation. Now people will ask, what is the principle of transmissibility? Suppose suppose there is an arbitrary body, okay, and now we want to apply a force F at point P. Okay, so principle of transmissibility says that on the same arbitrary body we can apply the same amount of force at different point, at different point, but the condition is the line of action, the line of action of force F must be same. It means the both situations are equivalent actually, you know principle of transmissibility says that we have advantage of moving the force vector to another point. moving the force vector to another point. But the condition is the line of action must be same. Okay, though. So from the principle of transmissibility says that these two situations are equivalent. Okay. Now let's move forward. So first we will talk about what is vector. Okay. So we all know that vector has what? Vector is a quantity which has magnitude and direction. Okay. For example, velocity, force, acceleration, etc. Okay. So definitely if you talk about force, then force vector can be written as magnitude of F and its direction. Okay. So here N signifies the direction of force F. So in vector quantities, we always talk about two things, magnitude and its direction. Now we will use some definitions like what is unit vector. Unit vector, it is a vector of unit magnitude. Okay. Suppose there is a force F. So how will you determine the unit vector? Unit vector can be determined by dividing the force, I mean any vector, by its magnitude. Okay. So we can say that the magnitude of unit vector is always 1. Okay. Now we will move to the equal vectors. What are equal vectors? Okay. Equal vector says that suppose we have a vector P. Okay. And we have also another vector Q. And we are saying that the magnitude of vector P and magnitude of vector Q are same. What are the magnitude of vectors? Means the length of this vector. Okay, that is called what? Magnitude. And the length of this vector, that is called what? Magnitude. Okay, and it is saying that the magnitude of P and Q are same. And also the direction, यानी कि which means the direction of P is parallel to the direction of Q. So we can call P vector and Q vector are what? Equal vectors. Okay. So for equal vectors, direction and magnitude must be equal. Okay. Now we will move to the negative vectors. Negative vector. Suppose there is a vector P and there is another vector Q, but its direction are directly opposite and its magnitude are same, then we can call it as a negative vector. Okay, so we can clearly see that P vector and Q vector has the same magnitude but its direction are directly opposite, so we can call P is negative vector of Q, so we can write is P vector minus times of Q vector. Okay. Okay, now we will move forward to the vector law of addition. Vector law of addition, that is actually very important. Okay, vector law of addition says suppose we have a vector P and another vector Q is such that the tail of vector Q is directly connected to the head of P, and there is another vector R such that its tail is connected to the head of Q, and there are so many vectors like that, so many vectors. So the vector law of addition says if we connect the tail of initial vector to the head of final vector, which is called R, we can write here T because that is same. Okay, so if we connect the tail of vector P to the head of the final vector, then vector law of addition says R vector must be equal to summation of all those vectors. Okay, so that is the vector law of addition. And the same thing, there is another law which is called parallelogram law. I will say these two are same, but parallelogram law are frequently used because we will deal with only two vectors. Parallelogram law of vectors. It says, suppose there is a vector P and there is another vector Q, and if I want to determine the resultant of these two vector, then the resultant of these two vector will be the diagonal of parallelogram, which is created by connecting these parallel lines. And this parallel line is nothing but the vector P, and this parallel line is nothing but the vector Q. And by the definition of equal vector, we can clearly see that the magnitude of this is equal to this and the direction is also same. Then definitely this P and this P will be same, and this Q and this Q will be same. Then the parallelogram law of vector says the resultant will be nothing but the P plus Q, and this resultant will definitely coincide with the diagonal of this parallelogram. And I will say this parallelogram is nothing but the vector law of addition, and it can be clearly seen that this P and there is another vector Q, and the tail of Q is directly connected with the P, then R will be the sum of vector P plus Q. Okay, so there is nothing new. Okay, now let's take an example to find the resultant of forces. Okay, so let's take, suppose there is a bolt. Okay, and we are applying a force P of 40 Newton, and there is another force which is Q, which has a magnitude of 60 Newton, and the angle between these two forces is 30 degree and this one is 30 degree. Okay, now find the net force acting on the bolt. Okay, so what is the procedure? We already know that first, definitely we can also apply the formula to find the resultant, but here I will follow the resolution of forces. Okay, first I will resolve the force P. So in all x direction, what will be the total forces? If we resolve this 40 Newton, what will be 40 cos 30 degree? And if we resolve this force in the x direction, first I should show the coordinate axis. Okay, now, so if you resolve this force in x direction, what will be the value? 60 cos 60 degree. Okay, and what are the total forces in y direction? That is nothing but 40 sine 30 degree plus 60 sine 60 degree. Okay, so what is the resultant? Resultant will be Fn, F net, that is nothing but the square root of fx square plus fy square, that is approximately 96.7 Newton. Okay, so let's take another example. Yeah, solve it. Are you guys trying at least?
Yes, sir.
Yeah. Has somebody got an answer?
So solving part B.
Okay, okay. Okay.
So solved, sir. Solved.
Yeah, yeah. What is the answer? The first one?
Sir, first one का है 3660.25 and
Yeah.
2588.
Yeah, yeah. Good. Good.
And
Correct.
second वाले का है अल्फा इक्वल टू 60 डिग्री आ रहा है सर.
Yeah, yeah, yeah. Good. Yeah, it's correct. Okay, so let's solve it for others. Okay. So here it is saying that the boat is applying for there are two boats. Okay, the boat A and B are applying force on this tugboat. Okay, so and when it is applying, then definitely at point B, we are talking about at point B, and the boat when boat is applying force, then definitely there is a tension in the string. Okay, T1, and there is another tension is T2. Okay, and the angle, this angle is 30 degree and this angle is alpha, and it is saying that the resultant of these two force is 500 lb, okay, 500 pound. Now it is saying that this force is resultant, okay, then definitely the resultant of these two tension is 500 lb. Okay, so can somebody tell me if I apply 500 lb in this direction, what will be the situation? Obviously there will be an equilibrium. Okay, are you satisfied? Did you get it? If I apply 500 lb, 5000 lb in this direction, the system will be in equilibrium. Okay, then definitely this problem can be solved by Lami's theorem. Okay, so the first, it is saying that alpha is 45 degree. Okay, so what is the Lami's theorem? Lami's theorem says T1 divided by this angle. What is this angle? If it is a 45 degree, then it is also 45 and plus 90. Then sine 90 plus 45 degree equal to T2 divided by what is this? Sine 90 plus 60. Okay, equal to 5000 divided by what? Sine 75 degree. Are you getting my point? Are you guys with me? So what will be T1? T1 will be 5000 divided by sine 75 into what? What will be the value of sine 90 plus 45? Cos,
1/√2.
yeah, cos 45, and T2 will be what? 5000 into cos 60 degree divided by sine 75 degree. And the approximate value of this will be 3660 lb, and this one is what? 2588 lb. Okay, did you get my solution? Hello, did you get my
Yes,
solution?
Yes,
yes,
sir.
sir.
Yeah, yeah. And that is actually easiest way. Okay, because otherwise you have to find the resultant and you have to solve, I think you have to solve quadratic equation like that. And the second problem, it is saying that the value of alpha for which the tension in rope 2 is minimum. Okay, the tension in rope 2, I mean it is talking about T2. So if it is alpha, suppose if it is alpha, then what can we say? T2 divided by, okay, sine, it is asking about rope 2. Okay, so if it is alpha, then what will be the angle? Sine 90 plus 60 equal to what? 5000. Okay, divided by what will be this angle? Sine 30 degree plus alpha. Did you get it? So T2 will be what? 5000 into cos 60 divided by sine 30 plus alpha. Now it is asking the value of alpha for which the tension in rope 2 is minimum. It is asking about the minimum. Okay, then you can easily interpret it. If you want T2 as a minimum, then what will be the value of alpha? If T2 is minimum, it is definitely mean that this quantity must be maximum. Okay, and this quantity will be maximum when this angle will be 90 degree. Okay, so what will be the value of alpha? 60 degree. Did you get it? Hello?
Yes, sir.
Yeah. So these two are
Sir,
problems. Okay. Have you any doubt?
sir, yes, sir. Please
Yeah.
kindly repeat the T2, sir. How
T2.
to, sir, 90 degrees, sir?
Oh, okay, okay. This 70 degree. Oh, where it is 70 degree? Where is 70 degree? There is nothing
Sir,
70
no
degree.
sign.
Yeah.
இல்ல, no, sir, 70 degrees, sir. How the sine 30 plus alpha, alpha equal to 60 degree?
Oh, yeah, yeah. Actually,
Yes,
the
sir.
problem
Yes,
is
sir.
it is asking the value of alpha for which tension in rope 2 is minimum. Okay. It is asking about T2. Okay. Did you get it?
Yes, sir.
Yeah.
Yes, sir.
By Lemmy's theorem, you can write it like this.
Yes,
Okay.
sir.
Now you want to
Yes, sir.
find T2 to be minimum. Okay. Now see
Yes,
this
sir.
ratio. This ratio will be minimum when this quantity will be maximum. Okay.
Yes,
Because
sir.
the
Yes, sir.
numerator is constant. You cannot vary it. Okay. But denominator is a
Okay, sir.
variable. Where is alpha? Okay. And
Yes, sir.
sine is always maximum. Its value will be 1 when the angle is 90 degree.
Yes,
Okay.
sir.
So alpha must be
Yes, sir.
what? 60 degree. Did you get
Yes,
it?
sir. Yes, sir.
Yeah.
Yes, sir. Sir, and one more doubt, sir, please.
Yeah. 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 Ask it.
The unit of force is 5000 LB. What do you mean by LB, sir?
LB is actually pound. Okay.
Pound is that.
Yeah. Yeah. It is
CJ is right,
another
sir?
unit of force.
FBS, FBS.
Yeah. Yeah.
Yes, sir. Okay, sir.
Okay. Okay.
Yes, sir.
Now let's move forward. Okay. Now another topic is equilibrium of a particle in plane. Okay. Okay. So if I talk about a particle, then I have already talked it about it that the particle does not have any moment, torque like that. Okay. So everything will be force. Okay. And if you want to put this situation in equilibrium, then definitely all the resultant, I mean resultant of all these forces must be what?
Zero, sir.
Yeah. So this is the idea. Resultant of all forces must be what? Zero. And if you resolve all these forces into two component, I mean x and y, then what will be? F, can you write it? Summation of fx, okay? I cap plus summation of fy, j cap equal to 0. Now, if you separate I component and j component separately, then definitely you can write what? Summation of fx equal to 0 and summation of fy equal to 0. Okay. Now let's move to the FBD of a particle, not a rigid body. Okay. FBD of a particle. What is the definition? The definition is it is the way, it is the way of isolating, isolating to visualize, visualize all forces. Okay. Forces acting on the particle. Sorry for my writing. Actually, my writing is very bad. Particle. Okay. So this is the FBD. Okay. So let's an example. Suppose actually we have already solved one example, but yeah, let's some another example. Suppose there is a wire. Okay, and this angle is 50 degree. This angle is 30 degree, and you are applying a force 400 lb. Okay, now the question is what is t1 and t2? What is t1 and t2? The answer is simple. I mean t1 divided by cos 40 degree, How it is 40 degree? I mean, this one is 40 degree, this one is 60 degree. Then T1. T1 opposite angles are what? T1 divided by, I mean, this is 40, then it is 50 plus what? T1 divided by what? If it is 50, 40, then 50 and 90. Okay, so T1 will be sine. Actually, T1 will be T1 divided by sine 90 plus 50 degree equal to 2T2 divided by sine 90 plus 30 degree equal to 400 divided by sine 100. Okay, by this way you can determine T1 and T2. Okay, so this is the equilibrium of a point. Now I will give one problem, okay, and try to solve it. See this problem and try to solve it. Fourth problem. Actually, there are
Yes, sir.
five
Sir,
situations.
300,
Yeah.
300.
A, B, C, D, and E. What is the answer for A?
300,
Yeah,
300, अब B का, फिर C का 200, फिर 200, फिर 150.
yeah, it's correct. Okay. So, what is the actually my actually process? So, here string is same. Okay. If you make an FBD, okay. So the load is 600 here. Okay. And this part, suppose this force is F, so by equilibrium you can write it F equal to what? 600 lb. Okay, now this F will act force on this pulley. Okay, now we make diagram for this pulley, then this force will be like this, and on the surface of this pulley strings are passing. Okay, I mean same string is passing, so it will apply force like this, T and T, because this T will be same, because you know why? Because the string is same, so tension will be also same. If tension is not same, then definitely what? The property of a string is different. I mean there is an assumption, an assumption for this string is that the string must be inextensible. Okay, and it must be rigid also. If it is not inextensible, then definitely there will be what? Deformation in this string. And if there is a deformation, then definitely what? This T must be different. Okay, so that's why here will be T, then this T will be also same. So from the free body diagram, here F is 600, then we can write what? 2T equal to 600, then T equal to what? 300 Newton, sorry, 300 lb. So the first answer is what? 300 lb. And now see this situation. From this situation again, the tension in the string will be all over the string will be what? T, and the situation is same like this only. Okay, again same T are acting on opposite direction, and these two T will be balanced by what? 600 lb. The answer will be what? Same, 300 lb. Now see this situation. Here there will be three tension. There will be three tension in the pulley. One will be like this, another will be like, I mean you can consider it is a vertical. Okay, there is no angle mentioned, so it must be vertical, approximately it must be vertical. Okay, so again T is equating with 600 lb. Again what? 3t equal to 600. So t equal to what? 200 lb. So answer will be 200 lb. And the same situation with this also. There are three strings. So answer will be again what? 200 lb. Now see this situation. Okay, this situation is slightly different. Okay, for this situation there are two pulleys. Okay, the first pulley, if you see the first pulley, okay, it is balancing by weight 600 lb. Okay, and the string is same. See, string is same, then definitely tension will be what? In this pulley, I'm talking about this pulley, the tension will be t like this, tension will be t like this. But there is another string. Okay, sorry, I'm talking about this, right? Okay, okay, yeah, but there is another arm here. Okay, that arm force we don't know. Okay, but when you draw a BD of this pulley, okay, another pulley, so this force will be equal to with this force because body is same. Okay, now this force will be balanced by these two tension force. Okay, t. Then what? F will be equal to 2t. Then here F will be what? 2t. Now there are t plus 2t. What? There is 4t. Okay, there is 4t equal to what? 600 lb. Then t will be what? 150 lb. Okay, the answer will be 150 lb. Are you guys with me?
Sir, the
Yes,
string
sir.
is same, the tension will be same, sir.
What?
So if the string is same, the tension will be same.
Yeah, if the string is same, the tension will be same. Okay,
Yes.
yeah.
Sir, can we check it by cutting the strings
Which
e
part? Which part?
in a e question?
E. E.
Yes, sir.
Well, I have already cut it, na? I have already cut it. By this pulley,
Um,
yeah, by this pulley I will cut it. Okay, the tension will be t here, the tension will be t here, and there is a force F that we don't know what is the amount. Okay, then this force and this force will be same by this pulley. Okay, if you see this pulley, then this force and this force will be same because system is in equilibrium. Okay, but this force is balanced by what? These 2t. Okay, so F equal to what? 2t. Now if we see again this pulley, then there are 4t. T plus 2t, there are 4t. Now 4t is balanced with what? 600 lb. That's why t will be what? 150 lb. Did you get
no,
it?
sir. I was telling that as a string is same, na. So if we cut it at above the whatever you have cut it,
Yeah, so what's the
if we cut
problem?
it at
I'm assuming na tension is same na, everywhere tension is same. What's the problem then?
no means without considering small pulley, whatever you have considered small e of is equal to 2t, we can directly get 4t
Yeah,
is
you can
equal to.
also. I mean, you can also assume it. I'm actually trying to break it. Okay, you can also
Okay,
assume
sir.
it like there are 40 t. But the problem
Yes.
is here. I mean, answer is same. Okay, but the problem is, here there is no string. Okay, here there is no string.
Yes.
String is here. Okay, that's why I broke into two part. Okay, because there is no string, but definitely this force will be balanced by what? These 2t, because that arm is connecting by these two string. Okay, that's why answer will be same. Okay,
Okay. Yes.
yeah, any doubt?
सर एक चीज पूछनी है सर
Yeah,
अगर एक स्ट्रिंग एक्सटेंसिबल होती तो क्या टेंशन सेम नहीं होता
अगर string extensible होता तो actually if string is inextensible, I mean extensible, then definitely if it has a mass, suppose if it has a mass, suppose.
नहीं सर मैं मास की बात नहीं कर रहा बस एक्सटेंसिबल है
But there is an assumption here. String is massless also. Okay?
हाँ सर
Yeah.
मतलब मेरा assumption है मासलेस है पर एक्सटेंसिबल है तो क्या होगा
If it is extensible and it is massless, that tension will be same because the system is in equilibrium. I mean that if the deformation is very small, If the deformation is very small, but string is extensible, the tension will be definitely same. But suppose deformation is finite, okay? Suppose deformation is finite, then definitely tension will be different. Definitely tension will be different. And if it is a mass, if it has a mass, okay, suppose the tension, suppose here t1 and t2, like that, you can definitely state it like this. Here is t1, here is t2. If it has a mass, okay, and it is expensing, then definitely there will be an acceleration, okay, then there will be an acceleration. And if there is an acceleration, then definitely these t1 and t2 will not be balanced to each other. Are you getting my point?
Yes, sir.
Yeah, that's why if string is same, if a string is same, the tension will be same. But the condition is string must be massless, inextensible, non-deformable. Okay?
The last case, I'm not able to understand it.
What?
So this last case E number problem, I'm not able to understand it.
What
How
is
the
what is the problem here?
and not able to understand how does the upper pulley get the tension about
Oh, okay,
150
okay.
lb.
Wait. I will try to convince you. Okay? There are two pulleys.
Okay.
Okay?
Yeah.
I will create two free body diagram. Okay? First pulley and small pulley. Okay?
Okay.
Okay? The bigger pulley has weight 600, okay, 600
Okay,
lb,
sir.
and it has two tension, t1 t and t, okay.
Yeah.
Now there
Yeah.
is an arm, okay, there is an arm.
Yeah.
If you remove this arm, then definitely this arm will apply a force F, okay.
Yes. Yes.
Okay, now it's over. Now
Yes.
we go to the pulley, this pulley, okay, smaller pulley. This force will be balanced by this force. I mean, if the arm is same, then definitely this force and this force will be same. Are you with me?
Yes, sir.
If you make free body diagram of arm, okay, okay, this F and this F must be same because system is in equilibrium, okay. This
Yes, sir.
FPD is
Yes.
of this arm, okay. So this F,
Okay, sir.
yeah. Now if you see this pulley, it has two tension, T T. Then what will be
Yeah.
the value of F? That will be 2T. Now F can be equated with 2T. Now there are 4T. 4T is balancing with 600 lb. That's why the answer is 150 lb. Are you with me?
Okay, got it. Got it, sir.
Yeah. Now we will move to the rigid body. Okay. Rigid body, but not a point mass. Okay. Rigid bodies. What is the definition of rigid bodies? Can you tell me?
Distance between 2 points
Under the
on the
action of force, deformation not take place, sir.
Yeah. Actually, most of the bodies in engineering is considered to be rigid body, because in engineering we usually, I mean, in engineering I'm talking about engineering mechanics, okay, because in engineering mechanics we assuming that there is no deformation, okay. So there's no deformation, which means what? The body is rigid body, okay. So what is the definition? Rigid body, if, sorry, if the relative displacement. Why I'm talking about relative displacement? You are saying that 2 points are 2 point will not move. Okay. If the relative displacement between any 2 points on the body will remain same, okay, after motion, okay, then it will be called as rigid body, okay. Why it is saying that relative displacement? Suppose there is a body, okay. First it is in the rest. Now the relative position is this. Now if you move it, okay, now if you move it, then even after the moving, suppose the displacement between these 2 points are say d, okay, now if you move it, the distance between these two must be also same. Okay, so we have to talk about the relative displacement. Okay, so that's why we, in general, there is no such example of rigid body. Okay, so in engineering mechanics, definitely there will be some deformation, but that deformation is very small. Okay, so there will be no problem in considering rigid body. Okay, so in whole engineering mechanics, we only talk about rigid body. Okay, now next move to the external and internal forces. Can somebody tell me what is external and internal forces?
Sir, the forces which are acting external to the body are called as external forces,
Yeah.
The force
whereas the forces
produce motion are external forces.
Okay. Anyone else?
whereas the forces which are acting inside the body are called as internal forces.
Okay.
Like stasis.
Yeah, you're correct.
Sir, the
External
force
forces,
developed with,
external forces,
sir,
yeah,
the force acted by external surfaces, sir.
yeah, exerted by another
Ex- yes, sir.
another
Another
body.
surface. Yes, sir.
You cannot say another other body, by other bodies on the rigid body under consideration. Okay, now what is internal force? These these forces are actually are actually hold together the particles inside the rigid body. Okay, it is saying that the main purpose of internal force is what? Actually hold together the particle inside the rigid body. Did you get it? What is the main purpose of internal forces? Suppose I will take one example. Okay, suppose you have a truck and there is a string and you are applying a force F. Okay, and suppose there is a cart here. Can you tell me which forces will be external, which forces will be internal?
F is the external force.
Sir,
Yeah,
F is the external force.
yeah. Okay,
The tension on the two bodies internal force.
yeah. If you talk about the a body of this truck, okay, if we make a body of this truck, then this force will be definitely what? External force. Okay, we will list it. External force. Okay, the first one is what? F. Now any other external?
Friction,
Friction. Okay,
The spring
any,
force.
suppose the
force,
surface is frictionless, There is no friction.
The spring force which is behind
I'm
it.
not
Actually, that
sure,
is not,
but
I will say that is not a spring actually. There is an arm which is connecting this.
sir, I'm not sir.
Yeah.
And the tension,
The weight
Tension.
force, sir.
What?
Weight force, sir.
What? Wheel force.
Weight force.
Wait,
Weight
wait.
force, sir. Weight.
Uh, can you tell me again?
Sir, weight and
Weight
normal.
force, sir.
Normal.
Weight. Yeah. Weight.
Yes, sir.
Weight is
Weight,
also
sir.
an external force. Why it is an external? Actually, it is coming out of the body. Why it is external force?
सर मैं नॉर्मल कहना चाह रहा था नॉर्मल फोर्स
Okay. Okay, normal force. Yeah.
एंड जो टेंशन लगा रहा है जो कनेक्टिंग जो रॉड है टाइप
Okay. That is not an external force.
इस बॉडी के लिए तो एक्सटर्नल है ना
No.
and if we consider just the truck as a system,
Yeah.
then
Another,
tension force.
yeah, another external force is the weight of the body. Now you will say why weight is an external force. That is actually external force because Earth is pulling this. Earth is pulling this externally. Okay, that's why the weight of the body, I mean, the weight of the truck is also an external force. Now we will see what is the situation here. Okay, if I see the connecting point, if I see the connecting point, suppose it is a metal, I mean it is a fixed, and I want to remove it. Okay, I want to remove it. Then the surface between these two, okay, if I if I consider this as a single body, this as a single body, as a single body, then the surface here and the surface here actually touching it. Okay, so that's why it is what internal force. Okay, and these two must be equal. Otherwise, if it is not equal, then there will be an acceleration. And I am saying that the system is in equilibrium. That's why these two force must be equal. And this is what internal force.
Here we are considering the whole, the both the trucks as single systems.
Yeah, single. I mean, any part of the body considered can be considered as a single body. Because the whole body, I mean, the whole rigid body is what consists of lots of millions of particles, and all those particles are what bind together. Okay, all those particles are bind together, and every particle, if we pick any particle is acting equal and opposite forces with each other. Okay, if we talk about these particle which are connecting with this, then definitely whole this particle will act force to this, and this particle will act force on this. That's why these are what internal forces. I mean, the tension on the string is also an internal force, because if you break, suppose string, if you break, suppose a string here T, here T, if you break in between them, then definitely at the breaking point there will be a tension, and that tension is also equal to what, this T. Okay, because system is in equilibrium and this T must be equal. If these two are not equal, then the system is in what, not in equilibrium. That's why what, it is internal force. Are you getting my point?
Yes.
Yeah.
Yes, sir.
Yeah. Now the next topic is moment of a force. I'm going little fast, okay, because syllabus is not small, and we have to cover it what, 9 weeks. That's why I'm going fast, okay, because these are very fundamental and very small things, and I want to finish it as early as possible. Okay, so suppose an arbitrary body, and I'm assuming coordinate axes are like this and the origin is here. And I'm acting a force F. I'm applying a force F at point P like this. Okay, and this position vector O to P is R. Okay, then from the definition of moment, it says m naught, I mean moment about point O, is nothing but R cross F. Okay, R cross F. And here m naught is also a vector quantity. Okay, and the direction of m naught can be determined by using the right hand thumb rule. I mean, if you put your fingers along the direction of, if you put the finger along the direction of P and curl in the direction of force F, then the direction of thumb will says the direction of what? Moment. Okay. And vector m naught can also be written like r, magnitude of f, sine theta, and n cap. What is n cap? N cap is nothing but the direction of this normal vector, and this normal vector is what? This normal vector is perpendicular to this plane, where in the plane of r and f. And what is theta? Theta is nothing but the angle between r and f. Okay, so this is the definition of what? Moment. Now you can also see that here r, you can separate r sin theta, right? R sin theta, F, and n cap. What is R sin theta? If you make, I mean, if you extend this line, okay, this is theta, this is also theta. Then what is this? This is what? Magnitude of R sin theta. Means what? This is D. And this is D is what? It is the perpendicular distance. See, it is the perpendicular distance. Okay, it is the perpendicular distance between the force F and the axis of rotation. Okay, so we can also say that D, what magnitude of m naught, you can magnitude of F. Okay, because I have converted m naught into magnitude, so magnitude of m naught can be written as D into F. Not, it is not a cross product actually, it is a simple multiplication. Okay, now suppose there is a particle in three-dimensional space. There is a particle in three-dimensional space which has position vector r, and on this particle P, there are lots of forces are acting. A, B, C, and D. And I want to determine the moment about point O. Okay, so how will we determine? We can determine as m naught equal to r cross f naught. Okay, r cross, and what is f naught? F naught is summation of all these forces acting on point P. So we can write it a vector, b vector, c vector, dot dot dot, equal to what? R cross a vector plus r cross b vector plus r cross c vector, dot dot dot. Okay, so what does it say? It is saying that if there are lots of forces are acting on point P, and if you want to determine the net moment, okay, if you want to determine the net moment, then that will be nothing but the summation of all the moment by individual forces. Okay, so that's what it is saying. Okay, now let's solve one problem. Yeah, try this problem number 5. Are you guys with me?
Yes, sir.
Yeah, try to solve problem number 5.
1200 Newton per meter. The answer is 1200.
Answer is, yeah, first one is 1200.
$57.75.
Yeah, it's correct. What about C?
Would be 50.
How much?
50.
Yeah, it's correct. What about other guys? Are you guys solving or not?
Yes, sir.
Yeah, yeah.
10
Right.
मीटर सर डी का 10 मीटर आ रहा है
Okay. Actually, I have not solved it, so I will solve it now. I
so
don't
सर
know the
सर
answer.
10 इंच
Sir, no, sir. D won't be, sir, 10 meters, sir.
Okay, okay, okay. We will see. Okay. Oh, the question is 100-pound vertical force is applied to the end of lever, okay, which is attached to shaft at O. Determine the moment of. Yeah, it is easy. Okay, this one is very easy. First, what will you do? You will draw a vertical, and you will determine this perpendicular distance. Okay. Or you can also do one thing, if you put origin here, okay, and now take this point A and now connect O to A and you name it as a position vector R. Okay, so what is R? R is nothing but what? 24 cos 60 degree I cap plus 24 sin 60 degree J cap. Okay, what is F vector? F vector is completely vertical downward. Okay, what is 100 lb what? Minus 100 lb J cap. Oh, why it is not erasing? Okay, now I want to determine the moment about point O. Okay, so what will you do? R cross F. Okay, so 24 cos 60 degree I cap plus 24 sin 60 degree J cap cross minus 100 LB J cap. Okay, now you already know I cross J equal to what? K. J cross K equal to what? I. K cross I equal to what? J.
J.
Okay. So 24 cos 60 will be what? 12 into minus 100 into I cross J. That will be what? K. Okay. Plus 24 sin 60 into minus 100 into J cross J. That will be equal to what? 0. Okay. So what will be the answer? Minus 1200 LB. Am I doing any wrong here? No, it's correct. Actually, what is the advantage of using this method? Can you tell me?
Sir, we could get the direction as well.
Yeah, actually, we are getting the direction. That is the advantage. Am I doing wrong here? 24 cos 60 plus, if I put origin here, 24 cos, everything is correct, right?
Yes.
सही है sir.
Yeah, everything is, yeah, it's correct. Okay, so that is the main, that is one method. Now the second one, I mean, if there is no point of any direction, okay, when you talk about only the magnitude, then what will you do? You will determine easily what? D, that is the perpendicular distance. What is the perpendicular distance? That is nothing but 24
24
cos
cos
60.
60.
That is nothing but 12. Okay, and now we know that magnitude of m naught equal to what? F into D, that is
F into D.
12 into 100, that is 1200. But the problem is we don't know the direction. Okay, so that is the main thing. Now we will solve part B. It is asking that the horizontal force applied at A that create the same moment about O. Okay, what is the moment about O? That is 1200. Okay, now we want to equate it with what? Horizontal force applied at A. We want to apply here a horizontal force F. Okay, and there is a moment 1200. Now what we have to determine? The perpendicular distance. Now what will be the perpendicular distance? 24 sine 60 degree. Okay, so that will be equal to F into 24 sine 60 degree. Okay, if you solve, you will get F equal to what?
2078.
57.7 lb. Okay, now we'll see part C. The smallest force applied at A that creates the same moment about point O. Smallest force. Suppose we are applying an arbitrary force. Okay, we don't know the direction. Okay, you are applying just an arbitrary force. Okay, we don't know the direction. Okay, about point O. Okay, so what will you do? 1200 equal to what? F into D sin theta. That is the definition of cross product. Are you guys with me?
Yes, sir.
Yeah. So if we write F equal to what? 1200 divided by D sin theta. That is 1200 divided, what is D? 24 sin theta. Now see, it is asking the smallest force. How F will be smallest? Can you tell me how F will be smallest?
Sir,
Tell me. If sin theta will be,
if it is
if sin theta will be 1, I mean the denominator, when denominator
uh,
will be maximum, and the maximum value of denominator will be what? 24, because sin theta will become 1. Okay, so F max will be what? 1200 divided by 24, that is nothing but what? 50 lb. And you can see that theta must be 90 degree, you know, that theta must be what?
pardon.
90 degree. It means what? This theta will be what? 90 degree. I mean, this force must be like what? This force must be like this.
Inversely proportional to that.
Yeah, did you get it? This force must be
Yes, sir.
like this. That is the time when we get the maximum value of what? Moment. Okay, I mean the maximum minimum value of F. Okay, now any doubt here?
So can you kindly repeat it?
Which one?
See, sir.
Yes, sir. How is the minimum force?
Okay, can you see this? I don't know the theta. Okay, I don't know the theta. Okay, I'm just applying arbitrary force in arbitrary angle. Okay, now we will use definition of moment. What is the definition of moment? M not equal to what? Fd sin theta. Okay, that is D. Fd sin theta. Okay, and we don't know the theta. Okay, I'm just want to determine the minimum value of F. So F can be written as F equal to 1200 divided by what? D sin theta, because that is the definition of what? Cross product. Okay, now I want to determine the minimum value of F. So how F will be minimum? When its denominator will be maximum. Did you get it? Tell me.
Yes.
Yeah,
Yes,
when
sir.
the
Yes, sir.
denominator will be maximum, and the denominator will be maximum when sin theta will be maximum, and the maximum value of sin theta will be what? 1.
90 degrees.
Yeah, when theta is 90 degree. That's why I have written F max equal to 1200 divided by 24. That is exactly equal to what? 50 lb. Did you get it?
Yes, sir. Sir, actually, the theta must be the angle between D and F, right, sir? So,
No. Actually, I have written no. Did you see the definition of torque? Did you see the definition of torque? What is F? What is theta here? Theta is nothing but the angle between position vector and force vector. Okay? The angle between position vector. Here position vector is what? Here position vector is this. Okay? Tell me.
yes.
Yeah. And the position and the direction. I did wrong here.
Sir, actually, it should be the angle
Yeah,
included by
yeah.
them.
That angle must be 90 degree. This. Oh, sorry. Okay. Okay. Thank you. That must be theta. Okay. But the answer will be same. I mean, theta must be what? 90 degree. If you rotate theta to 90 degree, the situation will be like this. Okay. Did you get it?
Yes, sir, yes.
Yeah. Now, actually, we have skipped C and D part. What is C? C, D. The smallest force F applied at A. That, I mean, I have solved it, right? How far from the shaft A 200 lb vertical force? That must to create the same. I mean, the question is same. There is nothing different. We are applying force F here, right? Now,
So theta
yeah,
is in
what will be the perpendicular distance? 24. I mean 12. What? Cos 60 degree. Okay. So what will be the answer? 1200 equal to F into 12 cos 60 degree, right? F divided by 100 times. So 100 divided by cos 60 degree. What will be the answer? 200 lb. Am I right? You guys are also getting same answer? Are you guys also getting same answer?
Yes, sir.
Tell me.
और
Yeah.
इसमें तो डिस्टेंस है ना,
What?
इसमें तो डिस्टेंस पूछी है ना डी वाले में, ये 240 एलबी कहाँ लगाएंगे?
Oh, yeah. How far from the shaft? Okay. Oh, yeah.
That would be 5, sir.
Okay, yeah,
इसका तो
definitely.
10
Actually, that must be D, right?
Yes, sir.
Yeah, that is
That would be
D.
12
Okay,
by
and the here that is 1240, 240,
Hmm.
right?
That would be
Okay.
5.
So D will be what?
5.
Yeah, okay. 1200 into cos 60 is 2 divided by 240. Okay, that is 100. How it is 100?
सर 100 ना 10 है.
Sir, I wanted come, sir. 5, sir.
Okay, wait.
Because-
I am doing something wrong here. Vertical.
10 meters.
Yeah, 10. It is actually, we are getting 10. 10.
Sir, it's
10,
right
10 inch.
24, sir. 2.
विजय तेरा कितना आ रहा है?
5 आ रहा है.
Yeah, I will get 10, right?
सर 10 ही सही है.
Yeah, 10. 10 is correct. We will
Yes.
get 10. Okay. Here. We will get 10. Okay. Now I will give E and E part for you. I mean, you can think it. Whether any of the force obtained part is equivalent to the original force. Can you tell me the answer?
Sir, one thing
part.
I have to ask you.
What?
Sir, why did you multiply with 2, sir?
2 where? Where 2?
Because AP,
Oh, actually that is cos 60, right?
root 3 by.
Yeah.
Oh, okay. Now I got it.
Yeah, that is cos 60.
Okay,
So divided by cos 60 means what? Multiplied by 2 in the numerator.
Okay, now I
Okay.
got it.
Now tell me the answer E.
सर कोई भी बराबर नहीं है, मतलब
Yeah,
कोई भी
definitely. Moments are same. I am assuming that moments are same, but the problem is forces are different. Did you get it? Moments are same, but the forces are different. I will
Sir,
definitely
equivalent force means
what
same magnitude and the same direction, sir.
what
Equivalent force means same magnitude and same direction of
same
force.
direction. I mean, it want to ask that if in all this situation, are you getting the same situation of forces and moment about point 2 on this member? I mean, in every situation, we are solving for the same moment, right? But we are getting different forces. Okay, we are getting different forces like this. Here we are getting 57.7 lb. Here we are getting 50 lb. And when you see the situation, I mean, suppose in all the situations, I mean the effect of 57 lb about point O, the effect of moment, I mean the moment about point O by applying this force and this force, the moment will be same. But the problem is forces are not different. Okay, the effect of force is translation. Okay, the effect of force is translation, but the effect of moment is what? Rotation. The effect of rotation will be same, but the problem is translation will be different. That's why in all this situation, all those forces will not be equivalent. Did you get it?
Yes, sir.
Yeah. Now see this problem.
So, how we theta is desired? I mean, we can measure the theta from the other side also.
What? Can you please repeat?
Uh, how can we determine that theta? I mean, we can measure the theta from the other side also. The theta is the angle between position vector and force, isn't it?
Yeah. No,
So,
you can put any. I mean, you can put anything. You can put anything here theta, but the problem is here sine theta. What is the definition of sine theta? Here theta must be the angle between what? Displacement, I mean this position vector and f. Okay, if we put any arbitrary angle, but anyhow you have to put accordingly. I mean that theta must be accordingly. Suppose the am I right? I got your question.
actually, what I'm asking was the complementary angle of that theta is, I mean, 180 minus theta. Can we take that theta as
Theta
angle
what?
between the two
Suppose
vectors?
I am taking theta this.
Yes.
Okay, okay, no problem. Then what is the angle between these? Because we have to put, suppose this angle is alpha, and what will be the theta? Theta will be what? 180 minus alpha. Okay,
Yes.
because
Yes.
this theta must be the angle between position vector and force. Now put this theta equal to here 180 minus alpha. Anyhow you will get what? Sine alpha, and anyhow you have to maximize sine alpha. And according to this, that theta alpha must be what? Again 90 degree. So again there will be what? This orientation. Did you get it?
Yes, sir. But can we say that alphas, I mean the product as f cross sine alpha,
F
f into
cross
r sine alpha,
what
f
what
into
what
r sine alpha, f into r sine alpha.
R sine alpha? I'm not getting your
Yes.
question actually.
Actually, can we take that alpha as the theta, angle between the position vector and force? Alpha is also the angle between position vector and force, isn't it?
No. Yeah. Actually, you got confused. Yeah. So you are saying that the angle between R and F is alpha. So why I'm writing a 180 minus alpha here? That is your question. Is that your question?
Yes, sir.
No. Actually, the angle between two vector will be decided by the angle between tail points. You cannot consider this angle. Okay, because you can extend this vector like this. Okay, so you have to consider this angle. That is nothing but 180 minus alpha, not this angle. This is not the angle between R and F. Did you get it?
Okay, sir.
When you
So
measure the angle between two vectors, then you have to take care about this, whether these two tails are matching or not. Here, head are matching with the tail of this vector. So that is not the angle between R and F.
Okay, sir. So
Okay.
it must be between the tails.
Yeah. The angle between two vectors will be always, you have to take care about that the tail is matching or not. Okay.
Okay, sir.
Yeah. Any other doubt? Now solve this
No, sir.
problem. This is actually very easy.
Sir, 1092.
Oh yeah, you have solved it. Definitely. Yeah, good.
Yes, sir.
What is the answer? Moment about point B.
Uh, so therefore, 0.2 meter in 0.2 meter with I cap plus 0.116 is 0.16 and J cap, and
I
here
want
the
to know the answer.
1092.9.
No. Actually, that is wrong.
So because force is 800 and cos 60 degree I cap plus 800 uh, sin 60 degree, then that is coming
No,
like that.
actually, answer is -2 not 3.
2 not.
Yeah.
I'm getting minus 2 not 3.
Yeah, it is. It must be minus 2 not 3. See, I will solve it. Okay. Now, take coordinate axis here.
Okay, so 2 not
Okay.
2, sir. So,
2,
okay,
yeah,
sir, 2 not
approximately.
2.5.
Yeah, approximately.
Yes, sir.
I have put x-axis here, y-axis here. Okay. So, what is the formula of moment about point B? R cross F, right? Okay, where R is the position vector of the point of application of force. Okay, so this will be what? Position vector. Okay, this will be what? RA. Okay, now you have to find RA. What will be the RA? RA is nothing but the what? Minus C, because here this horizontal distance is negative x direction. Okay, so minus 2 I cap, right? Plus, and what is the vertical distance? 160 mm. Okay, so that is 0.16 j cap. Am I right? Now, what is the force
Yes,
vector? Force vector is what? 800 cos 60 degree I cap plus 800 sine 60 degree j cap. Okay, now just put this here. What will you get? Moment
that
about
will be
point B, R
okay.
cross F. Okay, so okay, do you know how will you determine the A cross B vector by using the matrix? You all know that, right?
Yes, sir, but for the previous
Okay,
that, yeah.
so definitely what? I, J, and K. And here ax means what? X component of R, that is what? Minus zero point 0.2. Y component of R, 0.16. And Z, there is no Z component, so 0. Now here is 800 cos 60 degree. Here is 800 sine 60 degree and 0. Okay. When you solve it, what will you get about I component? See, everything will be 0, right? Delete rows and column, you will get this multiply by this multiply by this, you will get 0. Minus j, delete rows and columns, what will you get? This multiply by this minus this multiply by, again you will get 0. Plus k, what will you get? Multiply by this into this minus zero point 0.2 into 800 sine 60 minus 0.16 into 800 cos 60 degree. Am I right? What will you get? Approximately, you will get minus 203 what? Newton meter. Did you get it?
Yes, sir.
Is there any problem, any doubt?
Actually, I just
So how to find that resultant direction? I mean, for
Resultant
the moment.
direction? No, no. Where is the resultant? Okay, this actually you have to resolve it, right?
Clockwise or anti-clockwise.
Yeah, if you resolve it, then what will be the x component? 800 cos 60, and y, what is y component? 800 sin 60. So that is the thing. Okay.
Okay, so can we use that thumb rule here?
Thumb rule. Okay. So you want to determine, you want to find by using the force into perpendicular distance, right?
Yes, yes, sir.
So that is also not so difficult. Okay. So you have to find the perpendicular distance by this force. Okay. Actually, first resolve it. Okay. First resolve it. That is the situation, right? Fx, and that is the situation what? Fy, right? By using this force, what will do the perpendicular distance? This one, and that is nothing but what? 160 mm, right? Equal to 0.16 meter. So by using this component, I mean, if you use m1, right, then what will be the moment? F into perpendicular distance, right? So what will be the F? 800 cos 60 into 0.16, right? And what is the sense? Sense is this, right? So you can consider what? K cap, right? What is m2? M2 is by using this force vector. So for this force, what will be the perpendicular distance? 200 mm. So, and what is the force component? 800 sine 60 into zero point 0.2. And what is the sense of rotation? Sense of rotation is again this, right? Again K cap. Now add this m net equal to what? M1 plus M2. You will get the same result. See, you will get same result. But the problem is you are getting here negative sign. And now you are getting here positive sign. So sign is not so important here because you know the sense of rotation is same. Okay. Sense of rotation is, you can assume this as a minus k. See. Okay. So we'll get the negative answer. Right? Is there
Okay,
any
sir.
doubt?
No.
Yes, sir. Clear, sir.
Yeah. Now solve this problem. I will suggest use this method, because this one is actually one short answer, one short solution. Here you have to resolve it and everything you have to do. But here, you can directly start from this determinant. See this, use this problem. I will demonstrate it. See this problem, I will demonstrate it. How will you find directly? Because I mean, without doing anything. Solve this. Solve problem number A, okay, and we will give I will give you problem number B as homework, okay. What is the position vector, right? If we put coordinate axis like this, x and y, then what will be the position vector? Negative minus zero point 0.1 I cap, it is also negative, minus 0.2 j cap, right? What is the force component? You extend like this, okay. If this angle is 25, this angle is also 25, then what is the force component? Force component is nothing but what? 300 cos 25 I cap plus 300 sin 25 j cap. Now find moment about what? D I j k minus 0.1 minus 0.2 0 300 cos 25 degree 300 sine 25 degree 0, and we already know that I and j component will be what? 0. directly we will find what? K component. So minus 1 into 300 sine 25 degree plus 0.2 into 300 cos 25 degree. Okay, you will get around 41.7 Newton K cap. Did you get it?
Yes.
Yes, sir, it's clear.
Yeah. So we will wrap here. Okay. We will meet in next week. Okay. And the topic of the next week will be friction and applications. Okay.
Sir,
Yeah.
So,
Try to solve the B part also. Okay.
okay, sir. Sir, will you get that recording of that sessions?
Yeah. Yeah. Definitely you will get it. You will get on NPTEL Gate YouTube channel.
Okay. Would you mind sharing your mail ID? If we
No, no,
can do.
bro. Sorry.
Okay, okay.
Yeah. Okay.
so, so
Sir,
can you shift the timing from
Yeah,
6 to 7?
you can actually email me in my personal email ID. Okay. If you have any doubt, you can email me.
Sir, can you kindly, sir,
Yeah.
So,
can you kindly show me the questions which you did in the like first 15 minutes because I missed it.
What?
So can you kindly show the questions which you had done in the beginning of the class?
First question. This one.
This was the first question, sir.
No, no, I think this was the first question. No, no, actually I've solved it. Where I solved it? Yeah, this one, right?
Yes. Yeah. Okay. Sir. So can you kindly show me the pulley question?
Pulley. Okay, yeah. Pulley question. Yeah, that was there. Yeah, this one. What is the problem here?
I just wanted to note the problems.
Okay, yeah, noted.
Sir, actually, I missed few problems, so therefore, will I get that PPT like if you share
Uh,
it on your
okay, actually
mail?
it will be very difficult to you share the PDF of this, because it is very difficult actually, because how will I share all those for a personal account, because I don't have your so much details. I mean the list of candidates I don't have, so it will be very difficult to you share.
No, sir. Actually, I'm telling that if you share this on your G Drive, then if you share us your G Drive link, then we could access that.
Yeah, okay, I will try it. Okay, I will try it definitely. Okay,
Okay, sir.
so, so,
sir,
yeah.
so can you shift the timing from 6 to 7?
No, actually, it is very difficult, because I have also very load, I have to do my research work, so it is very
Okay,
difficult to shift.
okay, sir.
Okay,
sir, I have one question, sir, please.
yeah. Is there any problem?
Sir,
Yeah,
sir, I have one question, sir.
yeah. Ask.
Sir, I don't know how to identify the direction of tension force, sir.
Okay, direction of tension. Okay, so what is the problem here?
Sir, how to
Direct.
identify that?
Okay, see,
Sir, no here, sir. In first sum, sir.
hmm?
Both sum, sir.
Both, which
Both
one?
sum, sir. Not there, sir. First sum, sir.
First sum. Okay, the very first problem or this one?
Uh, no, sir. Problem number 1.
Problem number one. This
This
one.
is the problem number 4, sir. This, sir. Okay. Yes,
Okay.
sir.
So what is the problem here? Okay. The sense of this, right?
Yes, sir.
Actually, I have used the trick,
Yes, sir.
in this problem, it is
Yes,
saying
sir.
that 5,000 pound is the resultant of these two tension force, right?
Yes, sir.
Okay. It is saying that
Yes,
the
sir.
5,000 pound is the resultant, you know.
Yes, sir.
So,
Yes, sir.
but if you suppose here 5,000, right? Here 5,000 pound.
Yes, sir.
I mean, you can
Yes, sir.
remove these two as a single force 5,000, right?
Yes, sir.
If 5,000 pound is resultant of these
Yes,
two,
sir.
then easily you can remove these two tension force and put 5,000 pound here like this, right?
Yes, sir.
Okay. But I
Yes, sir.
want to determine the tension in the rope. Okay. I want to determine the
Yes, sir.
tension in the rope. So, what I
Yes,
used?
sir.
I used that why I cannot apply 5,000 in this direction so that the system is in equilibrium. If you put
Yes, sir. Yes, sir.
if you put
Yes, sir.
5,000 in the opposite direction, then definitely the system will be in equilibrium, right?
No. Yes, sir. Yes, sir.
So
Right,
I
sir.
apply Lami's theorem after that. Okay.
Yes, sir.
Yeah,
Yes, sir. The
that was the
500.
idea.
Yes, sir. Yes, sir.
Yeah,
Yes, sir. For the equilibrium condition, we want to opposite sense.
yeah, that's why. Okay.
Yes.
Definitely this
Okay.
5,000 is
Yes,
not
sir.
acting in this direction. Actually, 5,000 is the resultant of these two.
Yes, sir.
Okay. But I have applied directly opposite to that
Yes,
so
sir.
that the
Yes, sir.
system will be in equilibrium. Right?
Equilibrium. Yes, sir. It's otherwise it's not equilibrium. It move along the same side.
Yeah, yeah, yeah. Now it is clear, right?
Yes, sir.
Okay.
Yes, sir. Clear, sir. Thank
Yeah.
you, sir.
Okay, see you next week, right? Thursday, 6 to 7 p.m.
Yes, sir.
Okay?
Okay, sir.
Okay.
Yes, sir.
Bye bye.
Okay, bye.
Yeah.
Yes, sir. Thank you. Thank you, sir. Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.